Hi everyone, and welcome to TLDR containers. It's expected that containers and container management is going to take 2 weeks. The learning outcomes for these 2 weeks are being able to describe the advantages and disadvantages of containers such as Docker and be able to identify the reasons why we might use containers, be able to implement and use a container management software such as Kubernetes. What is a container? The most classic example that you're going to see used a lot is think of shipping containers. So if you picture any shipping containers, shipping boxes, things like that, they are standard sizes that you can pack things in so that it's actually easier to send things. So for example, if you've ever moved, you know that it's easier to pack a box and move a box than it is to pack, for example, oddly shaped things. With containers in software, you actually aren't shipping the operating system and the software. What you're actually sending out is the code and the dependencies. So it's actually one of the ways that we can get a little bit more usage out of some of our hardware because we aren't having the same amount of duplicates that we would have with, for example, virtual machines. Some examples of times that you would actually be using a container is every time you're going to go use Google, such as your Gmail or do searches, you're actually doing that within a container. Containers are actually really useful for developers because it's an easy way for a developer to create something and send it out, because the developer knows that they will be able to send it out and it will run no matter where it's being sent. There's also something called microservices that containers are really useful for. So one of the things that happens with a lot of group projects is group projects can be hard to manage because if everybody is working independently, it can sometimes be tough for everything to come together. Microservices, because they are breaking the applications into many small parts, it's easier to send somebody to complete one of the parts and actually put it together faster than if everybody is working on the same project together. You also have the ability to make sure that it is able to be reproduced because you already know what your container is set up to be. You know that you have isolation because you're able to keep your applications separate. You can create a repository so you can actually have some pre-made containers, and you can also have containers that are easily disposable. So if anything goes wrong, containers are not resource heavy, so it's actually really easy to spin one up and get rid of one very quickly. Containers are slightly different than virtual machines. Containers actually virtualize the operating system, whereas a virtual machine virtualizes the hardware as well. So you can see from the image on the screen, the virtual machine is going to end up running with the hypervisor, and then that's going to, each virtual machine will have the kernel, the libraries, and the programs. Whereas a container actually doesn't use the same setup exactly. It takes away the hypervisor and the kernel. So the container is only holding the program and the library. So they're also smaller, which is why they're less resource heavy. Currently, Docker is the most popular container on the market as of summer of 2020. This might change in the future, but they are currently the most popular. There are other container options out there. It's just most of the time you end up running into Docker. Container images. You want to be able to hold and distribute all of your container images. You can do things like public containers that are easily shareable, private containers. You can do things like self-host containers. There's also something called Docker Hub where they have the ability to have easily shared Docker containers. Container repository is related images. So the example is the Python repository. You can actually set up it's set up as a container repository. If you'd like to learn a little bit more about how that's set up, I've linked the Docker hub here so that you can go check that out, so that you can see what a container registry looks like in practice. The activity that I want you to do is actually try this Docker tutorial on one of your servers so that you can start to get a little bit of hands-on experience with it. Feel free to pause me here while you do this. Container management is one of the ways that we can work with multiple containers. This is also known as container orchestration engines. So if we're talking about setting up 1, 2, 5, 10 containers, maybe we would be okay doing that manually. But if we do something like, for example, Kubernetes, we can actually scale up with the amount of containers we're using very quickly and easily. For example, let's say we use our original example of when you've probably used a container without realizing it, doing a Google search. Think of how many Google searches are happening every minute of every day. If every single Google search is happening within its own container, that's not something that's even possible for people to do manually, which is why they need this container orchestration. Container orchestration gives us the ability to distribute containers, distribute resources, and check on our containers. It also gives us the ability to do things like health checks of the containers. So that means we can go in and say, hey, is this container being used? Is it taking advantage of all of the hardware that it needs? Is this taking advantage of and using more hardware than it needs? Some examples of container management software are Kubernetes, Docker Swarm, and Mesosphere. As of right now, Kubernetes is one of the more popular ones and seems to be going up on popularity. However, Docker Swarm is popular because it is native to Docker. It uses something called YAML to do the deployments. YAML is a little bit like JSON in that it's this mildly readable mildly human readable language to describe what something should look like. Downsides to Docker Swarm is it doesn't do load balancing or auto scaling, which is one of the things that makes Kubernetes a little bit more popular. Kubernetes is also referred to as K8. It's actually open source and it's started by Google. They are still using Kubernetes as part of the container as a service, and they are actually still working on it and developing it and things like that. As of right now, obviously that could change at some point. Some examples of other companies that actually use Kubernetes include Spotify, Capital One, Comcast, Pokemon Go, eBay. So you can see that there are a lot of companies that actually use Kubernetes in practice every day. It is currently the most popular and it uses YAML for the deployments. The vocabulary that it uses is something called pods. That is the groups of containers to make a single service. So Kubernetes is actually vendor agnostic. A node is the physical or virtual machine. A pod is one or potentially more containers that go together. When you deploy something, you are sending out a set of pods or set of containers, and you are trying to make sure that you have enough containers that your service works, but not so many that you have way more containers than you need. So that's some of the vocabulary that Kubernetes will end up using. The activity that I'm going to have you do for Kubernetes is actually going through the tutorial Kubernetes Basics. So if you follow this link, there's a quick tutorial for Kubernetes Basics so that you can see what it actually looks like in practice. Kubernetes does have vulnerabilities like everything else. Because containers are a newer technology, they're still sort of figuring out how all of these things work. Some of the downsides to Kubernetes. There's an increased attack surface. So every container that you're deploying might have different vulnerabilities. So every time you deploy a container, you're sort of putting a potential hole in your armor. One of the most difficult things that I know a lot of people and I personally find with Kubernetes is the configure. when you are setting up Kubernetes and doing the configuring and setting up the configs and everything, it is surprisingly confusing. That's why I wanted everybody to do the tutorial so that you can get an idea of what it's going to look like. But for whatever reason, configuring Kubernetes containers is very weird and very confusing and very easy to mess up. And it has nothing to do with intelligence or practice and everything to do with it's just confusing. So don't be surprised if Kubernetes is really difficult to configure right, and you'll actually see very well-known companies using Kubernetes with bad configures just because it's so confusing. For example, some services like Shodan actually make it easy to find places to attack. So you can actually see some of the vulnerabilities that are out there. It's always important whenever you have anything that you are showing to the public that you are paying attention to your attack surface. An example of this is actually from, I believe, last summer. Tesla, the electric car manufacturer, actually exposed part of their dashboard for their main Kubernetes API to the internet with zero authentication. Now, I would like to be clear that this didn't happen through malicious or hack or incompetence. Tesla pays a lot of money to get some very, very smart people working for them. This was completely an accident. And one of the big downsides to container orchestration software like Kubernetes is if you have a compromised container, you actually have a compromised cluster. If you are a fan of Terry Pratchett, you'll have heard the saying, it's turtles all the way down. If you aren't a fan of Terry Pratchett, I guess go read a Terry Pratchett book because they're awesome and hilarious. The lab for this week is actually installing Docker and Kubernetes on both of your servers. Once you have Docker and Kubernetes installed, I'm going to have you try installing Minikube and doing the Minikube tutorial. And then I also have an optional part where you can actually try out Ansible. So I have a tutorial for you to try out Ansible. Now for this lab, of course, one of the things that's going to be very important is that you do documentation. Document everything you've done to install Docker and Kubernetes. Once you've installed them, make sure that your documentation includes instructions for both distros and any troubleshooting that you had to do. Your target market for this is somebody who is familiar with technology and servers, but not at all familiar with containers or container orchestration management. If you have any questions, please let me know.